Hello, we are Juan Gutierrez and Kevin Figueroa, and in this project we present a technological solution focused on intelligent noise pollution monitoring in residential areas of Bogotá. The problem we aim to address is the excessive noise mainly generated by vehicles, motorcycles, and aggressive traffic behavior in residential neighborhoods, where this type of acoustic pollution can affect community well-being, create stress, and even increase the perception of insecurity. Our proposal consists of an IoT-based monitoring system supported by computer networking infrastructure, capable of detecting abnormal sound levels, transmitting information through a network architecture, and generating real-time monitoring alerts. Additionally, as part of the use of artificial intelligence tools, we developed this interactive visual simulation to represent the complete system workflow in a more dynamic and understandable way. In this general view, we can observe a simulated residential urban environment inspired by neighborhoods in Bogotá. Our project is not designed to monitor the entire city, but instead focuses on strategic residential areas where excessive noise pollution frequently occurs. The main objective is to provide a scalable solution, where small critical zones can be monitored initially, with the possibility of expanding the infrastructure to other locations in the future if needed. At this stage, we have the noise sensor, which represents the first component of the system. Its main purpose is to detect environmental sound levels measured in decibels. When the sensor identifies a value above the allowed threshold, for example, 74 decibels in an area where the acceptable limit is lower, it interprets the event as an abnormal condition. This component acts as the data acquisition point within our IoT architecture. Once the event is detected, the information is transmitted wirelessly to the IoT gateway. This device acts as an intermediary between the sensors and the main network infrastructure. Its role is to collect the incoming sensor data, organize the information, and prepare it for transmission to the rest of the system. This architecture allows efficient and centralized communication between multiple distributed devices. After reaching the gateway, the information is forwarded to the network switch. This component belongs to the local area network, or LAN, and is responsible for managing internal communication between devices connected within the same network segment. At this stage, data packets are organized and routed efficiently before moving to higher layers of the network architecture. Next, the information reaches the router, which is responsible for directing network traffic beyond the local infrastructure. The router serves as the connection point between the residential monitoring network and external communication systems. This device plays a critical role in ensuring that the collected data can be transmitted towards centralized remote services. After the router processes the information, the data leaves the local network and travels through the WAN, or Wide Area Network. This stage represents communication through the internet, allowing information to move from the monitored residential environment to remote centralized infrastructure. Including this layer is important because it demonstrates how a real network architecture extends beyond a simple local network and connects to distributed remote services. Once the information reaches the central server, the processing phase begins. The server stores historical records, analyzes detected events, and centralizes the system's core logic. This enables event tracking, long-term monitoring, pattern analysis, and preparation of the processed information for real-time visualization. Finally, the processed data is displayed in the monitoring dashboard. From this interface, administrators can observe real-time alerts, noise levels, infrastructure status, and event logs. For example, in this scenario, the dashboard displays an excessive noise alert in a specific residential zone. This monitoring interface allows centralized supervision of the entire system and enables faster response to abnormal environmental conditions. In conclusion, this project presents a technological solution that integrates Internet of Things, computer networking architecture, and intelligent monitoring to address a real problem related to noise pollution in residential communities. Through sensors, network communication, centralized processing, and real-time visualization, we demonstrate how networking infrastructure can be applied to urban environments in order to improve community quality of life. Additionally, we complemented our Cisco Packet Tracer network simulation with artificial intelligence tools to create this visual interactive demonstration, making the system workflow easier to understand. Thank you very much.